Hi, this is James Gardner at Sydney Tech Geek, and this is the next video in my Rec 2020 coverage for the demonstration we did down in Melbourne, Australia, to a number of DOPs and colour graders. Now, what I wanted to cover in this video was something what a DOP said to me, and it sort of generated quite a lot of interest between some of the people there. There was people from camera makers and other bits and people type of background there, and one of the most important questions was, am I shooting with my cameras now the right stuff for going to this new Rec 2020, and as such high dynamic range, which is coming down like a train on us due to all these high dynamic range televisions coming out this year? Well, that's a really interesting question. Now, I want to give you my perspective as someone who studies it on a technical level, but you know, there is actually science and what you can think determined based on numbers, and there's actually reality, and they're not always the same. And this is a very interesting question because they would ask me, okay, I want to shoot now, but I want to be able to bulletproof it, so if the guy comes back to me in a year's time when all these HD televisions are coming out and he wants to put his content on the premium streaming service in the area, which has launched its new high dynamic range premium service, and they want their content to appear on that service, how should I shoot my content to make sure that they can come back to me, back to my master files, and produce a high dynamic range result? Well, that's a really good question, don't you think? Because if it is coming as fast as it looks like, you know, we could be making quite a lot of high dynamic range by mid-time next year. You know, it'd be quite a reasonable demand on it. If, you know, this Christmas there's high dynamic range televisions all over the showroom, the general public get to see it and they're starting to buy it in droves, and streaming services market it to them a lot, and that's a major source of content viewing in the future. He wants to make sure that the content he makes can appear on those premium services. My natural reaction to that is, well, high dynamic range, or there's some general rules of thumb. Let's go through them. Standard definition, like a lot of people like to talk in stops, and these new cameras can do 14 up plus stops, 15 stops worth of dynamic range. Now, what does that mean? Well, I suppose it tells us that it's the variability of how much from dark to light that it can store. And then when we talk about putting it into a standard dynamic range picture like we see in 709, it pretty much is about four stops. So when you go to the post process, really what you're doing, you're deciding how to bring this 14 stops worth of data, and you're squeezing it down to the 4 stops. So you're throwing lots of data away. So there's a lot of data being thrown away, and as such, there's technologies like S-log type logarithmic compression technologies and other things that we use, which when you're going from this type of master to a master with only that much dynamic range, it's very efficient, works really well. But when we go to high dynamic range, and instead of from 4 stops, we're going up to 10 stops. So first thing to say here is that what you're shooting today is high dynamic range based. You can use it for high dynamic range, but it really depends on how you store it and what you store in your files or in your master files. Realistically, you want to go with a raw workflow, and that really made a few people uncomfortable. Like, raw tends to bring to people very large files, very difficult to deal with, and no thank you, I'm not very happy with Red because it's given us that sort of image in the past, because Red's J2K compression of their raw codec data, or the Bayer filter data, is very hard to deal with, and it's quite big. But there are alternatives to that. First of all, there's VC5, which is basically coming out of SMPTE now as a standard. There's reference codecs available, but there's a slight licensing issue with VC5 compression raw, and I'm hoping those involved will sort that out soon. You know who you are, and I hope you're listening. And, well, that would be a good compromise. But the big thing here is, what we're talking about raw, is we're talking generally in raw, it's a 14-bit depth color with a linear, not a logarithmic way of storing the data. So just the basics, what's the difference between linear and logarithmic? Well, our eyes don't see everything exactly the same. So log basically what it does, we've got code values, and the code value is used to store a certain amount of data. when we use a logarithmic type curve, what we're basically saying is that we'll use more code values to store more information in the parts of the image where our eyes can discern the difference better. And in the brighter areas generally, where our eyes can't really discern the difference as much, we'll throw that data away. So what does that mean? Well, it kind of means that we may be using a 8-bit container, or storing an 8-bit with a logarithmic compression, which means that even though we're storing an 8-bit, down in the lower parts of the image where we need to see more detail, we're actually using more than 8-bit. And in the higher parts of the image where there's a lot of brightnesses and we can't really see as much, we throw a lot of that away, and it might be only 6-bit, for example. These are just rough indications, right? So in high dynamic range, where we can actually pull a lot of stuff out of the bright parts of the pictures, and we need to start grading those parts of the images, we can see into outside the windows and inside. Well, obviously that's not probably going to work as well if we use a logarithmic curve on that data, apart from a linear but high bit depth storage system. So really, you really should start considering going to a raw type workflow. Compressed is fine. There's some of the new versions from different manufacturers work very well. I'm really encouraging, and I have been for a while, if you've seen my videos in the past, the adoption of VC5, because that's a standard way of compressing a raw data in its generic form, so you can do the debaying, better quality outside of the camera, because real-time debaying obviously has its drawbacks. And you can do other advantageous things if you actually do store the raw data coming straight off the chip and then process it in the CPU in a slower, more accurate post-production process. So there's all these issues happening, but it really comes down to that the fact that I said raw to this guy. He wasn't terribly happy because it was expensive and he didn't want to do that. So he says to me, what's the compromise? How well will an S-Log3 sort of AVC file work? Because that's what he was using, and really it came down to it probably would still work quite well, but it is not ideal as doing raw. So how ideal is it? Well, I'm a theory person. This is a question of experience, and it's one of the main issues I want to come and try and trap some people who are doing this sort of work today and ask them what that compromise is. You know, this is a very, very important question, because there'll be a lot of you people out there, a lot of cameramen, a lot of producers who have a S-Log3 type master files, and they'll be thinking, can I go back and remaster to get onto these premium streaming services in 4K high dynamic range? It's going to be huge in the next couple of years. Do you want to be sitting in that list of content that's available at these premium prices? Of course, everyone's interested once they realize that this is coming. So yeah, it's a complicated question, but already just clearly that we must understand, you know, the best answer that I could give today is that if you're shooting with a typical 14 plus dynamic range camera, you've got high dynamic range stored in your data already. How effective that high dynamic range data is in those files, considering what you need to do with high dynamic range and what you can do, is really affected by how you store it, what codec you use, and how it uses those bits. Another rule of thumb, just to give you an idea, in a high dynamic range distribution, you need to be at least 10-bit, right? Even better. Well, the rule of thumb I've heard in some of the post-production people who are studying this is distribution must be 10-bit or better, and post-production must be 12-bit or better. So that gives you a straight understanding. If your codec is sort of in that sort of area of quality, you're doing quite well. But also when you get in the S-log curves, those issues, that's something that you need to suck it and see. You need to do it. You need to figure out what will and will not work. So that was a very interesting question. I'll follow this up more at NAB and probably ask some of the vendors more about this information. But this is a good starting point, and also prepare you now for something that's going to happen pretty quickly. And I really encourage you, if you're making any sort of content you think could be on a premium channel on a streaming service in the future, you better get on board on this now and figure out what you're going to do, and make sure that, you know, if there's a likely chance that you're going to remaster this in a 4K high dynamic range for distribution in the future, that you want to have the content ready to do that today, because it's a big missed opportunity. So yeah. Anyway, that's James Gardner, the Studio Tech Geek, on basically codecs and high dynamic range and what to look out for. So keep watching, and I'll have some more interesting topics coming. Bye for now.